Question 1. Cost-benefit analysis shows that upgrading the enterprise wireless network to a more secure protocol is financially viable, but the existing infrastructure has limited compatibility with the latest standards. The IT team needs to select a wireless security protocol that offers the best balance between robust security against current threats and manageable implementation costs, considering the potential risks of data breaches and the need to maintain operational efficiency. Option A. Implement WPA3 Enterprise, planning for phased hardware upgrades to ensure full compatibility and leverage its advanced security features. Option B. Revert to WPA2 Personal (PSK) with a focus on user education for password strength, as it offers a slight improvement over older protocols and is universally compatible. Option C. Deploy a proprietary, vendor-specific encryption solution that promises enhanced security but lacks widespread industry adoption and standardization. Option D. Continue using WPA2 PSK with a strong password policy, as it is compatible with all existing hardware and incurs no immediate upgrade costs. The correct answer is A. Implement WPA3 Enterprise, planning for phased hardware upgrades to ensure full compatibility and leverage its advanced security features. Explanation. Scenario analysis. The scenario presents a common challenge in enterprise wireless network implementation, balancing the desire for advanced features and performance with the practical constraints of budget and existing infrastructure. The professional is tasked with selecting a wireless security protocol that offers robust protection against modern threats while remaining compatible with current hardware and manageable within financial limitations. This requires a nuanced understanding of security vulnerabilities, protocol capabilities, and the total cost of ownership, extending beyond initial purchase price to include ongoing management, potential upgrades, and the risk of security breaches. The challenge lies in making a decision that is technically sound, financially responsible, and compliant with industry best practices for data protection. Correct approach analysis. The correct approach prioritizes a security protocol that offers strong encryption and authentication mechanisms, such as WPA3 Enterprise, which is the latest standard designed to address vulnerabilities found in older protocols. This choice is justified by its ability to provide enhanced protection against common attacks like brute force password guessing and rogue access points, aligning with the general principles of data security and privacy expected in enterprise environments. Furthermore, WPA3 Enterprise's support for protected management frames, PMF, adds another layer of security by preventing eavesdropping and manipulation of management traffic. While it might require some hardware upgrades or configuration adjustments, the long-term benefit of significantly improved security posture and reduced risk of costly data breaches outweighs the initial investment. This aligns with the principle of due diligence in protecting sensitive corporate and customer data, a fundamental ethical and professional responsibility. Incorrect approaches analysis. Choosing a protocol like WPA2 PSK, pre-shared key, presents significant regulatory and ethical failures. While it might be the most cost-effective in the short term due to compatibility with existing hardware, WPA2 PSK is known to be vulnerable to brute force attacks, especially with weak passwords. This lack of robust security exposes the network to unauthorized access, data interception, and potential compliance violations related to data privacy regulations. Ethically, deploying a known insecure protocol when better alternatives exist demonstrates a failure to uphold professional responsibility in safeguarding information assets. Opting for an older, less secure protocol like WPA or WEP would be a severe regulatory and ethical lapse. These protocols have well-documented vulnerabilities and are easily compromised. Their use would not only fail to meet any reasonable standard of network security, but would actively invite breaches, leading to potential legal repercussions, reputational damage, and significant financial losses. This would be a clear dereliction of professional duty to implement secure and reliable network solutions. Selecting a protocol based solely on the lowest initial hardware cost without considering its security capabilities or long-term support would also be professionally unsound. This approach neglects the critical aspect of network security, which is a fundamental requirement for any enterprise. The potential for future security incidents and the associated costs of remediation, legal liabilities, and reputational damage far outweigh any perceived short-term savings. This demonstrates a lack of foresight and a failure to adhere to best practices in network design and implementation. Professional reasoning. Professionals should employ a decision-making framework that begins with a thorough risk assessment, identifying potential threats and vulnerabilities relevant to the enterprise's data and operations. This should be followed by an evaluation of available security protocols against these identified risks, considering their effectiveness, compatibility, and scalability. A total cost of ownership analysis, encompassing initial deployment, ongoing management, and potential future upgrade costs, is crucial. Finally, the decision must be validated against relevant industry standards and regulatory requirements for data protection, ensuring compliance and ethical responsibility. This systematic approach ensures that the chosen solution is not only technically appropriate, but also secure, sustainable, and compliant. Question 2. To address the challenge of securing an enterprise wireless network while ensuring efficient user management and robust access control, which authentication and encryption methods should be implemented for optimal security and scalability? Option A. WPA2 Personal (PSK) with a single shared passphrase for all users. Option B. An open network with no authentication or encryption. Option C. WPA3 Personal (SAE) with a single shared passphrase for all users. Option D. WPA3 Enterprise with a radius server for centralized authentication. The correct answer is D. WPA3 Enterprise with a radius server for centralized authentication. Explanation. The scenario presents a common challenge in enterprise wireless network implementation, balancing the need for robust security with the practical requirements of user access and network performance. The professional challenge lies in selecting an authentication method that is both secure and scalable, while also adhering to industry best practices and potential regulatory considerations relevant to data handling and privacy, even if not explicitly stated as a specific jurisdiction's law for this exam. The 300-430 ENWLSI exam focuses on implementing these networks, implying a need for practical, secure, and efficient solutions. The correct approach, utilizing WPA3 Enterprise with a radius server for centralized authentication, represents best professional practice because it offers the highest level of security by employing individual credentials for each user and device. This method provides strong encryption and robust authentication, significantly reducing the risk of unauthorized access and data breaches. Centralized authentication via radius simplifies user management, enhances security policy enforcement, and allows for detailed auditing, which are critical for maintaining a secure and compliant network environment. This aligns with the general principles of network security and data protection expected in enterprise deployments. An incorrect approach involving WPA2 Personal (PSK) with a shared password fails professionally because it relies on a single, static passphrase for all users. This significantly increases the risk of credential compromise if the passphrase is leaked or shared inappropriately. Managing and revoking access for individual users becomes cumbersome, and there is no granular control or auditing capability. This approach is inherently less secure and not suitable for enterprise environments where individual accountability and dynamic access control are paramount. Another incorrect approach, using an open network with no authentication, is professionally unacceptable due to the complete lack of security. This exposes the network to anyone within range, allowing for unauthorized access to network resources, potential injection of malware, and interception of sensitive data. This is a severe security vulnerability and a direct contravention of basic network security principles. A further incorrect approach, implementing WPA3 Personal (SAE) with a shared password, while more secure than WPA2 Personal, still suffers from the same fundamental limitation of a shared secret. It does not provide individual user authentication or the granular control and auditing capabilities that WPA3 Enterprise offers. For enterprise environments, individual authentication is a critical security requirement. The professional decision-making process for such situations involves a thorough assessment of security requirements, user access needs, scalability, and manageability. Professionals should prioritize solutions that offer individual authentication, strong encryption, and centralized management. Understanding the trade-offs between different security protocols and authentication methods is crucial. In enterprise wireless networks, the default should always lean towards the most secure and manageable option that meets the functional requirements, which in this case is WPA3 Enterprise with Radius. Question 3. Governance review demonstrates that the current wireless network infrastructure is nearing end of life and a significant upgrade is planned. To ensure minimal disruption to critical business operations during the transition to a new enterprise wireless solution, which of the following approaches to impact assessment is most critical for a successful implementation? Option A. Conducting a detailed analysis of potential impacts on all critical business applications, user workflows, and interdependencies with existing wired and wireless infrastructure, alongside developing phased rollout and rollback plans. Option B. Relying on vendor-provided documentation and assuming that standard wireless deployment best practices will inherently mitigate all potential operational disruptions. Option C. Prioritizing the technical configuration and performance tuning of the new wireless access points, with a secondary consideration for user impact after the initial deployment. Option D. Performing a high-level assessment of network bandwidth requirements, and assuming that existing security policies will adequately address any new vulnerabilities introduced by the wireless upgrade. The correct answer is A. Conducting a detailed analysis of potential impacts on all critical business applications, user workflows, and interdependencies with existing wired and wireless infrastructure, alongside developing phased rollout and rollback plans. Explanation. Scenario analysis. Implementing a new wireless network infrastructure within an enterprise environment presents significant challenges, particularly concerning the impact assessment of potential disruptions. The core challenge lies in balancing the introduction of advanced wireless capabilities with the imperative to maintain uninterrupted business operations. This requires a thorough understanding of existing network dependencies, critical business processes, and the potential cascading effects of any network change. A failure to adequately assess these impacts can lead to significant financial losses, reputational damage, and regulatory noncompliance. The professional challenge is to proactively identify, analyze, and mitigate these risks before deployment. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously documents the potential effects of the new wireless network on existing systems, applications, and business workflows. This includes identifying all critical business functions that rely on network connectivity, understanding their tolerance for downtime, and mapping out dependencies between different IT components. The assessment should also consider the impact on end users, including training needs and potential productivity dips during the transition. By performing this detailed analysis, organizations can develop robust mitigation strategies, phased deployment plans, and effective communication protocols to minimize disruption and ensure a smooth transition. This aligns with best practices in IT project management and risk management, emphasizing proactive planning and stakeholder engagement. From a regulatory perspective, while the 300-430 ENWLSI exam focuses on technical implementation, responsible deployment inherently supports compliance by preventing data breaches or service interruptions that could have regulatory consequences. Incorrect approaches analysis. An approach that prioritizes rapid deployment without a thorough impact assessment is professionally unacceptable. This failure to analyze potential disruptions risks significant business downtime, leading to financial losses and potential breaches of service-level agreements, SLAs, which can have contractual and, in some sectors, regulatory implications. Such an approach demonstrates a lack of due diligence and a disregard for business continuity. Another incorrect approach is to focus solely on the technical aspects of the wireless implementation, neglecting the impact on end users and business processes. This oversight can lead to user dissatisfaction, reduced productivity, and a failure to realize the intended benefits of the new technology. Ethically, it represents a failure to consider the human element of technological change. A third incorrect approach is to assume that existing network documentation is sufficient for assessing the impact of a new wireless deployment. Network environments are dynamic, and outdated documentation can lead to critical dependencies being overlooked, resulting in unforeseen outages. This demonstrates a lack of rigorous investigation and can lead to significant operational failures. Professional reasoning. Professionals should adopt a structured, risk-based approach to impact assessment. This involves 1. Defining the scope of the assessment, clearly outlining what systems, application, and business processes will be evaluated. 2. Identifying all potential impacts, both positive and negative, across technical, operational, and business domains. 3. Analyzing the likelihood and severity of each identified impact. 4. Developing mitigation strategies for high-priority risks. 5. Communicating findings and proposed mitigation plans to all relevant stakeholders. 6. Establishing a feedback loop for continuous monitoring and adjustment throughout the deployment lifecycle. This systematic process ensures that all critical factors are considered, leading to a more successful and less disruptive implementation. Question 4. Benchmark analysis indicates that an enterprise is planning to deploy a new, high-density wireless network utilizing advanced spectrum sharing technologies. Before proceeding with the deployment, what is the most critical step to ensure compliance and prevent potential interference with existing licensed spectrum users? Option A. Conduct a thorough impact assessment to identify potential interference with existing licensed spectrum users and determine the necessity of obtaining new licenses or adhering to specific operational parameters. Option B. Focus solely on optimizing the new network's performance and user experience, deferring any regulatory considerations until after the network is operational. Option C. Assume that advanced spectrum sharing technologies inherently avoid interference and do not require further regulatory review. Option D. Proceed with the deployment and monitor for any reported interference issues, addressing them reactively as they arise. The correct answer is A. Conduct a thorough impact assessment to identify potential interference with existing licensed spectrum users and determine the necessity of obtaining new licenses or adhering to specific operational parameters. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of wireless network deployments and the critical need to adhere to established regulatory frameworks. The introduction of new wireless technologies, even within an enterprise, necessitates a thorough impact assessment to ensure compliance with existing regulations, prevent interference with other licensed spectrum users, and maintain the integrity of the overall wireless ecosystem. The challenge lies in balancing technological advancement with regulatory obligations and potential unintended consequences. Correct approach analysis. The correct approach involves a comprehensive impact assessment that proactively identifies potential conflicts with existing licensed spectrum users and evaluates the necessity of obtaining new licenses or adhering to specific operational parameters mandated by regulatory bodies. This aligns with the principles of responsible spectrum management and regulatory compliance, which are paramount in wireless network implementation. By engaging with regulatory authorities and conducting thorough interference analysis, the organization demonstrates due diligence and a commitment to operating within legal and ethical boundaries. This proactive stance minimizes the risk of regulatory penalties, service disruptions, and damage to the organization's reputation. Incorrect approach is analysis. Implementing the new wireless technology without first assessing its potential impact on existing licensed spectrum users and without verifying licensing requirements represents a significant regulatory and ethical failure. This approach disregards the fundamental principle that the airwaves are a shared and regulated resource. Failure to conduct an impact assessment could lead to unintentional interference with critical services, such as public safety communications or licensed commercial operations, resulting in severe penalties, legal action, and operational disruptions for both the organization and affected third parties. Furthermore, operating without the necessary licenses or in violation of spectrum usage rules is a direct contravention of regulatory mandates, leading to fines and potential revocation of operating privileges. Professional reasoning. Professionals tasked with implementing wireless networks must adopt a risk-based, compliance-first mindset. The decision-making process should begin with a thorough understanding of the relevant regulatory landscape. For any deployment, a comprehensive impact assessment should be conducted, including spectrum analysis, interference modeling, and a review of licensing requirements. Engaging with regulatory bodies early in the planning phase is crucial. When faced with potential conflicts or uncertainties, the professional's duty is to seek clarification from regulatory authorities and to prioritize solutions that ensure compliance and minimize negative externalities. This iterative process of assessment, consultation, and mitigation is essential for responsible and successful wireless network implementation. Question 5. The performance metrics show a significant increase in wireless client latency and packet loss across multiple access points in a specific building. What is the most professional and effective first step to address this issue? Option A. Immediately revert all wireless configurations in the affected building to a known stable baseline from the previous week, assuming a recent configuration change caused the problem. Option B. Initiate a detailed impact assessment to understand the scope of the latency and packet loss. Identify potential contributing factors, e.g., interference, client density, configuration changes, and determine the potential consequences of various troubleshooting actions before making any changes. Option C. Isolate the affected building's wireless network by disabling it temporarily to prevent further user impact while a full investigation is conducted. Option D. Deploy a new firmware version to all access points in the building, as firmware bugs are a common cause of performance degradation. The correct answer is B. Initiate a detailed impact assessment to understand the scope of the latency and packet loss. Identify potential contributing factors, e.g., interference, client density, configuration changes, and determine the potential consequences of various troubleshooting actions before making any changes. Explanation. This scenario presents a professional challenge because the network administrator is faced with a situation where performance degradation is impacting user experience and potentially business operations. The challenge lies in accurately diagnosing the root cause of the degradation without disrupting ongoing services or violating established network policies. The administrator must balance the need for immediate resolution with the requirement for thorough, evidence-based decision-making. The correct approach, which involves a systematic impact assessment before implementing any changes, represents best professional practice. This is because it aligns with the principles of responsible network management and adherence to operational guidelines. By first understanding the scope and nature of the performance issues, the administrator can identify potential contributing factors and prioritize remediation efforts. This methodical approach minimizes the risk of introducing new problems or exacerbating existing ones. Furthermore, it ensures that any proposed solutions are well justified and have a higher probability of success, thereby maintaining network stability and user satisfaction. This aligns with the implicit ethical obligation to provide a reliable and performant network service. An incorrect approach that involves immediately reverting to a previous, known good configuration without proper investigation is professionally unacceptable. This is because it bypasses the critical step of impact assessment. Such an action could mask the true underlying issue, leading to its recurrence or the introduction of new, unforeseen problems. Ethically, this demonstrates a lack of due diligence and a failure to thoroughly understand the network's state before making changes. It also risks disrupting legitimate network traffic that may have been functioning correctly, even if other areas are experiencing issues. Another incorrect approach, which is to immediately implement a broad set of network-wide configuration changes based on a single symptom, is also professionally flawed. This approach lacks the precision required for effective troubleshooting. It fails to consider that the observed performance metric might be a symptom of a localized problem or a complex interaction of factors. Implementing widespread changes without a clear understanding of the impact can lead to unintended consequences, including service outages, security vulnerabilities, or further performance degradation. This demonstrates a failure to adhere to best practices in network change management, which emphasizes targeted, well-tested modifications. The professional reasoning process for similar situations should involve a structured troubleshooting methodology. This begins with clearly defining the problem and gathering all available data, including performance metrics, logs, and user reports. Next, a hypothesis about the root cause should be formed. This hypothesis then guides the impact assessment, which determines the potential consequences of various diagnostic and remediation actions. Based on the impact assessment, the least disruptive and most effective course of action is chosen. This might involve further data collection, targeted testing, or controlled configuration changes. Throughout this process, clear communication with stakeholders and adherence to change control procedures are paramount. Question 6. Consider a scenario where an enterprise is planning to upgrade its wireless network security from WPA2 to WPA3. The IT department has identified WPA3 as a superior security protocol, but the network comprises a diverse range of client devices, including older laptops, mobile phones, and specialized EOT devices. What is the most prudent approach to ensure a successful and secure transition to WPA3? Option A. Deploy WPA3 only on newly purchased access points, leaving existing access points configured with WPA2 to maintain compatibility with older devices. Option B. Immediately enable WPA3 on all wireless access points across the enterprise to ensure the highest level of security is deployed as quickly as possible. Option C. Focus solely on configuring the wireless access points to support WPA3, assuming that client devices will automatically adapt to the new security protocol. Option D. Conduct a comprehensive impact assessment to identify all client devices and applications that will be affected by the WPA3 transition, plan for necessary client updates or replacements, and implement WPA3 in a phased rollout, starting with a pilot group. The correct answer is D. Conduct a comprehensive impact assessment to identify all client devices and applications that will be affected by the WPA3 transition, plan for necessary client updates or replacements, and implement WPA3 in a phased rollout, starting with a pilot group. Explanation. Scenario analysis. This scenario presents a professional challenge in a critical network infrastructure deployment. The challenge lies in balancing the immediate need for enhanced wireless security with the potential for disruption to existing business operations and the need to adhere to established change management protocols. A hasty or poorly planned implementation could lead to significant downtime, impacting productivity and potentially violating service-level agreements. Furthermore, without a thorough impact assessment, unforeseen compatibility issues with existing client devices or applications could arise, leading to user frustration and a failure to achieve the intended security benefits. Requirement to follow specific Cisco exam guidelines, 300-430 ENWLSI, implies a need for practical, implementable solutions that align with industry best practices for enterprise wireless networking. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously analyzes the potential effects of implementing WPA3 on all aspects of the wireless network and connected devices. This includes evaluating compatibility with existing client hardware and operating systems, identifying any applications that might be sensitive to changes in encryption protocols, and understanding the operational workflows that rely on the wireless network. This approach represents best professional practice because it prioritizes a phased, controlled rollout, minimizing risk and ensuring a smooth transition. It aligns with the principles of robust network design and implementation, where thorough planning and testing precede widespread deployment. By proactively identifying and mitigating potential issues, this approach ensures that the security enhancement does not inadvertently degrade network performance or availability, thereby upholding the integrity of the enterprise network and user experience. Incorrect approaches analysis. Implementing WPA3 immediately across all access points without prior assessment is professionally unacceptable because it disregards the potential for widespread service disruption. This approach fails to consider the compatibility of legacy devices or specific applications that may not support WPA3, leading to connectivity issues for a significant portion of users and potentially impacting critical business functions. This constitutes an ethical failure by prioritizing a security feature over operational stability and user accessibility without due diligence. Deploying WPA3 only on newly purchased access points while leaving existing ones on WPA2 is also professionally flawed. While it introduces WPA3 in a limited capacity, it creates a fragmented security environment and does not address the overall security posture of the enterprise wireless network. This approach fails to provide a unified security solution and can lead to confusion and potential misconfigurations, as users might connect to less secure WPA2 networks inadvertently. It represents a missed opportunity for comprehensive security enhancement and a failure to fully leverage the benefits of WPA3 across the organization. Focusing solely on the technical configuration of WPA3 on the access points, without considering client-side implications, is another professionally unsound approach. This overlooks the fact that wireless security is a two-sided equation. The client devices must also support and be configured for WPA3, Without assessing client compatibility and planning for necessary updates or replacements, the implementation will be incomplete and may result in many devices being unable to connect to the network, leading to user dissatisfaction and operational inefficiencies. This demonstrates a lack of holistic network planning and a failure to consider the end-to-end user experience. Professional reasoning. Professionals should approach network upgrades like WPA3 implementation by first establishing a clear understanding of the current network environment, including all connected devices, applications, and user workflows. This is followed by a detailed risk assessment, identifying potential points of failure or incompatibility. A phased rollout strategy, beginning with a pilot group or a non-critical segment of the network, allows for real-world testing and validation of the new configuration. Continuous monitoring and feedback mechanisms are crucial throughout the deployment process to quickly address any emergent issues. This systematic and risk-averse approach ensures that technological advancements are integrated effectively without compromising the stability and functionality of the enterprise network. Question 7. The investigation demonstrates that the planned implementation of a new enterprise-grade wireless security protocol, WPA3 Enterprise, across the organization's wireless infrastructure is likely to introduce unforeseen compatibility issues with a significant portion of legacy client devices and may impact the performance of certain real-time business applications. What is the most prudent and professionally responsible approach to proceed with this implementation? Option A. Deploy WPA3 Enterprise to a small, non-critical segment of the network first to gauge initial reactions and then expand deployment based on that limited feedback. Option B. Prioritize the security benefits of WPA3 Enterprise and implement it across all devices, accepting that some performance degradation and compatibility issues are unavoidable trade-offs. Option C. Proceed with the implementation of WPA3 Enterprise immediately to enhance security posture, addressing any reported issues on a case-by-case basis as they arise. Option D. Conduct a comprehensive impact assessment to identify all potential compatibility and performance issues, develop mitigation strategies, and plan a phased rollout based on the assessment findings. The correct answer is D. Conduct a comprehensive impact assessment to identify all potential compatibility and performance issues, develop mitigation strategies, and plan a phased rollout based on the assessment findings. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless network implementation, balancing the need for robust security and compliance with the practicalities of user experience and network performance. The introduction of a new wireless security protocol, while beneficial for security, can have unforeseen impacts on existing client devices and applications. The professional challenge lies in proactively identifying and mitigating these potential disruptions before they affect end users, thereby avoiding significant operational downtime and reputational damage. Careful judgment is required to assess the scope of impact, prioritize remediation efforts, and communicate effectively with stakeholders. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously analyzes the potential effects of the new security protocol on all aspects of the wireless network and its connected devices. This includes evaluating compatibility with existing client hardware and software, assessing potential performance degradation due to encryption overhead, and understanding how the change might affect critical business applications. This proactive, data-driven methodology ensures that potential issues are identified and addressed before deployment, aligning with best practices for change management and risk mitigation. From a regulatory and ethical standpoint, this approach prioritizes the continuity of business operations and the security of user data, fulfilling the organization's duty of care. It also demonstrates due diligence in adhering to security best practices without compromising operational integrity. Incorrect approaches analysis. Implementing the new security protocol without a thorough impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for potential disruptions to business operations and user productivity, which can have financial repercussions and erode user trust. This approach neglects the principle of least disruption, a key tenet in IT change management. Deploying the protocol to a limited set of devices without a broader assessment risks overlooking critical dependencies or widespread compatibility issues. This piecemeal approach can lead to inconsistent security postures and create a false sense of security, while still failing to address the full scope of potential impacts. It is ethically questionable as it does not ensure a uniform and secure experience for all users. Focusing solely on the security benefits of the new protocol while ignoring potential performance impacts is also a failure. While security is paramount, a network that is unusable due to performance degradation is ineffective. This approach overlooks the holistic nature of network implementation, where security, performance, and usability must be considered in tandem. It can lead to user workarounds that bypass security controls, creating new vulnerabilities. Professional reasoning. Professionals should adopt a structured change management process that includes a mandatory impact assessment phase for any significant network modification. This process should involve cross-functional teams, including network engineers, security analysts, and application owners, to gather comprehensive input. The assessment should utilize a combination of technical analysis, pilot testing, and stakeholder consultations. Decision-making should be guided by a risk-based approach, prioritizing the mitigation of high-impact, high-probability issues. Clear communication channels with end users and management are essential throughout the process to manage expectations and ensure transparency. Question 8. Upon reviewing the proposed implementation plan for a new enterprise-wide wireless network upgrade, which approach to assessing the potential impact on existing business operations best aligns with regulatory compliance and professional best practices for minimizing disruption? Option A. Delegate the entire impact assessment process to the network engineering team, with minimal consultation from business unit representatives. Streamline the technical evaluation. Option B. Conduct a thorough phased impact assessment involving key business stakeholders to identify critical dependencies, map potential disruptions, and develop mitigation strategies before and during deployment. Option C. Proceed with a direct, big bang migration of the new wireless network, relying on vendor-provided best practices and assuming minimal impact on current business workflows. Option D. Focus the impact assessment solely on technical performance metrics of the new wireless network, such as signal strength and throughput, without detailed analysis of business application dependencies. The correct answer is B. Conduct a thorough phased impact assessment involving key business stakeholders to identify critical dependencies, map potential disruptions, and develop mitigation strategies before and during deployment. Explanation. Scenario analysis. Implementing a new wireless network in an enterprise environment, especially one that impacts critical business operations, presents a significant professional challenge. The challenge lies in balancing the technical requirements of network performance, security, and user experience with the operational continuity and potential disruption to ongoing business activities. A poorly executed impact assessment can lead to unforeseen downtime, data loss, security vulnerabilities, and significant financial repercussions, all of which erode stakeholder trust and can have regulatory implications if data integrity or availability is compromised. The need for careful judgment stems from the interconnectedness of the wireless network with various business processes. Correct approach analysis. The correct approach involves a comprehensive and phased impact assessment that prioritizes business continuity. This means meticulously identifying all critical business functions that rely on network connectivity, understanding their tolerance for downtime, and mapping these dependencies to the proposed wireless network changes. By engaging with business stakeholders early and often, and by conducting thorough testing in a controlled environment before full deployment, potential disruptions can be identified and mitigated. This proactive methodology aligns with best professional practices by ensuring that the technical implementation serves business needs without jeopardizing operations. From a regulatory perspective, this approach supports compliance with data availability and integrity requirements by minimizing the risk of service interruptions that could affect regulated data. Incorrect approaches analysis. One incorrect approach is to proceed with a big bang deployment, assuming minimal impact and relying solely on vendor documentation for migration. This fails to account for the unique operational nuances of the specific enterprise and its critical applications, leading to a high risk of unexpected service disruptions. Ethically, this demonstrates a lack of due diligence and disregard for the potential negative consequences on business operations and employee productivity. Another incorrect approach is to focus solely on technical performance metrics during the assessment, neglecting the business process dependencies. While technical performance is important, it does not directly translate to business functionality. If the network performs technically well but fails to support a critical business application, the deployment is a failure. This oversight can lead to regulatory issues if the failure impacts compliance with service-level agreements or data handling regulations. A third incorrect approach is to defer the impact assessment entirely to the IT operations team without involving business unit representatives. This creates a disconnect between technical capabilities and business requirements, increasing the likelihood of overlooking critical dependencies or user experience issues. Professionally, this is a failure of communication and collaboration, and ethically, it can lead to decisions that negatively impact other departments without their input. Professional reasoning. Professionals should adopt a structured, risk-based approach to impact assessment. This involves 1. Stakeholder identification and engagement. Identify all relevant business units and key personnel. 2. Dependency mapping. Document all critical business processes and their reliance on network infrastructure. 3. Risk identification and prioritization. Assess the potential impact of wireless network changes on each business process, prioritizing high-risk areas. 4. Mitigation strategy development. Create plans to minimize or eliminate identified risks, including phased rollouts, rollback procedures, and contingency plans. 5. Testing and validation. Conduct thorough testing in simulated and live environments to validate the effectiveness of mitigation strategies. 6. Communication and documentation. Maintain clear and consistent communication with all stakeholders throughout the process and document all findings and decisions. This systematic process ensures that technical decisions are aligned with business objectives, minimizing risk and maximizing the likelihood of a successful and compliant wireless network implementation. Question 9. The assessment process reveals that a new enterprise-wide wireless network deployment is being considered to enhance mobility and collaboration. However, the initial proposal lacks a detailed analysis of how this new infrastructure will interact with existing data security protocols and comply with relevant data privacy regulations. Which of the following approaches best addresses this critical oversight? Option A. Conduct a comprehensive impact assessment that evaluates the wireless network's integration with current security policies, data privacy regulations, and operational continuity plans, identifying and mitigating potential risks before deployment. Option B. Prioritize the rapid deployment of the wireless network to gain immediate business benefits, deferring any detailed security and compliance reviews until after the system is operational. Option C. Focus exclusively on achieving the highest possible wireless network performance metrics, with security and compliance being secondary considerations to be addressed if issues arise post-deployment. Option D. Proceed with the deployment as planned, assuming existing security measures will adequately protect the new wireless network. The correct answer is D. Proceed with the deployment as planned, assuming existing security measures will adequately protect the new wireless network. Explanation. Scenario analysis. Implementing a new wireless network in an enterprise environment, especially one involving sensitive data or critical operations, presents a significant professional challenge. The challenge lies in balancing the need for robust, high-performance wireless connectivity with the imperative to comply with established regulatory frameworks and best practices for network security and data handling. A failure to adequately assess the impact of such an implementation can lead to security vulnerabilities, operational disruptions, and non-compliance, all of which carry substantial financial and reputational risks. Careful judgment is required to ensure that the proposed solution not only meets technical requirements, but also adheres to the spirit and letter of relevant regulations. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously evaluates the proposed wireless network implementation against existing security policies, data privacy regulations, and operational continuity plans. This assessment should identify potential risks, such as unauthorized access, data interception, interference with critical systems, and noncompliance with data handling mandates. By proactively identifying these risks, the implementation team can develop mitigation strategies, such as robust authentication mechanisms, encryption protocols, network segmentation, and thorough testing procedures. This aligns with the principles of responsible technology deployment, ensuring that new systems enhance rather than compromise the organization's security posture and regulatory standing. Adherence to these principles is paramount in maintaining trust and operational integrity. Incorrect approach is analysis. One incorrect approach is to prioritize speed of deployment and cost savings over a thorough impact assessment. This can lead to overlooking critical security vulnerabilities or compliance gaps, potentially exposing the organization to data breaches or regulatory penalties. Such a failure to conduct due diligence represents a significant ethical lapse, as it prioritizes expediency over the protection of sensitive information and the organization's legal obligations. Another incorrect approach is to assume that existing security measures are sufficient without a specific assessment of the new wireless network's unique attack surface and data flow. This assumption can result in inadequate security controls being applied, leaving the network susceptible to exploitation. Ethically, this demonstrates a lack of diligence and a failure to uphold the professional responsibility to secure the network infrastructure. A third incorrect approach is to focus solely on technical performance metrics without considering the broader implications for data privacy and regulatory compliance. While high performance is desirable, it must not come at the expense of safeguarding user data or adhering to legal requirements regarding data handling and storage. This narrow focus can lead to unintentional violations of privacy laws, creating legal liabilities and eroding user trust. Professional reasoning. Professionals should adopt a risk-based approach to technology implementation. This involves a systematic process of identifying, analyzing, and evaluating potential risks associated with a new system. The decision-making framework should prioritize the protection of sensitive data, adherence to regulatory requirements, and the maintenance of operational integrity. This includes engaging relevant stakeholders, conducting thorough threat modeling, and developing comprehensive mitigation plans before deployment. Continuous monitoring and periodic reassessment are also crucial to adapt to evolving threats and regulatory landscapes. Question 10. Examination of the data shows that a new enterprise wireless network deployment in a densely populated urban area in the United States is experiencing intermittent performance issues and reports of interference from neighboring businesses. The network utilizes the 4 GHz and 5 GHz unlicensed bands. The network administrator has been asked to optimize performance, but also to ensure full compliance with all applicable U.S. federal regulations. Which of the following actions is the most appropriate first step to address both performance optimization and regulatory compliance? Option A. Increase the transmit power on all access points to their maximum allowed levels to improve signal coverage and overcome potential interference. Option B. Conduct a thorough site survey to identify the least congested channels within the 5 GHz band and reconfigure access points to utilize these channels, while ensuring all transmit power levels adhere to FCC Part 15 regulations for unlicensed devices. Option C. Implement a dynamic frequency selection (DFS) protocol across all access points, regardless of the band, to automatically avoid interference from radar systems. Option D. Disable the 4 GHz band entirely to eliminate potential interference from legacy devices and focus solely on the less congested 5 GHz band. The correct answer is A. Increase the transmit power on all access points to their maximum allowed levels to improve signal coverage and overcome potential interference. Explanation. The scenario presents a common challenge in enterprise wireless network implementation, balancing performance optimization with regulatory compliance. The professional is tasked with configuring a wireless network that must not only meet user demands for speed and reliability, but also adhere to specific spectrum usage regulations. The challenge lies in understanding the nuances of these regulations and how they directly impact network design choices, particularly concerning channel selection and power levels. The correct approach involves a thorough understanding of the relevant regulatory framework, specifically the FCC, Federal Communications Commission, regulations governing unlicensed spectrum in the United States, as this is the assumed jurisdiction for the 300-430 ENWLSI exam unless otherwise specified. Best professional practice dictates that all network configurations must be compliant with these regulations to avoid legal penalties, interference with other licensed and unlicensed services, and potential disruption to critical communications. This includes selecting channels that are permitted for use, operating within specified power limits to minimize interference, and understanding duty cycle limitations where applicable. An incorrect approach would be to prioritize performance solely based on technical best practices without considering regulatory constraints. For instance, selecting the highest power setting or the most congested channel simply because it appears to offer the best signal strength without verifying its legality under FCC rules is a significant regulatory failure. This could lead to fines, forced network reconfiguration, and damage to the organization's reputation. Another failure would be to ignore the potential for interference with other services, which is a core tenet of spectrum management and a regulatory requirement. Ethically, it is a professional responsibility to operate within the bounds of the law and to avoid causing harm or disruption to others. The professional decision-making process should begin with identifying the applicable regulatory body and its rules for the target deployment region. This involves consulting official documentation from the FCC. Next, the technical requirements of the wireless network should be assessed, and then these requirements must be mapped against the regulatory constraints. If there is a conflict, the regulatory requirements must take precedence. This iterative process of technical design and regulatory validation ensures a compliant and functional wireless network. Question 11. Performance analysis shows a significant increase in Wi-Fi client retransmission rates and a slight degradation in overall throughput on a newly deployed enterprise wireless network. Initial investigation suggests that some access points might be operating at higher transmit power levels than initially configured, potentially due to automatic power adjustment features within the wireless controller. The network operates in a regulated environment where specific transmit power limits are enforced to prevent interference. Which of the following actions is the most appropriate and professionally responsible first step to address this situation? Option A. Consult the relevant regulatory documentation and the wireless controller's configuration guide to determine the exact transmit power limits and the behavior of the automatic power adjustment feature. Then adjust configurations to ensure compliance while optimizing performance. Option B. Immediately reduce the transmit power on all access points to a conservative baseline level to mitigate potential interference and ensure regulatory compliance. Then reevaluate performance. Option C. Disable the automatic power adjustment feature on the wireless controller to prevent further unintended power increases and revert to static, predefined power levels that are known to be compliant. Option D. Focus solely on optimizing Wi-Fi client configurations and quality of service (QoS) settings to improve throughput, as the retransmission issue might be a symptom of client-side problems rather than a regulatory concern. The correct answer is B. Immediately reduce the transmit power on all access points to a conservative baseline level to mitigate potential interference and ensure regulatory compliance, then reevaluate performance. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless networks, balancing performance optimization with the need to comply with evolving regulatory requirements. A professional challenge lies in interpreting performance metrics, understanding their potential impact on compliance, and making informed decisions that do not inadvertently violate regulations. The pressure to maintain high user experience and network availability can sometimes lead to overlooking subtle but critical regulatory implications. Careful judgment is required to ensure that any network adjustments are both technically sound and legally compliant. Correct approach analysis. The correct approach involves a thorough understanding of the specific regulatory framework governing wireless operations within the exam's jurisdiction, which is assumed to be US-based for this example, as no other jurisdiction was specified. This means consulting official documentation from bodies like the FCC, Federal Communications Commission, regarding spectrum usage, power limits, and interference mitigation. When performance analysis indicates potential issues, the best professional practice is to first identify if the observed behavior is within acceptable regulatory parameters. If it is not, or if there's a risk of exceeding them, the next step is to consult the relevant regulations to understand the permissible actions. Implementing changes that are explicitly allowed and documented within the regulatory framework, such as adjusting channel utilization within legal limits or employing interference mitigation techniques that are compliant, represents best professional practice. This ensures that network improvements do not lead to noncompliance, which could result in fines, operational disruptions, and reputational damage. Adhering to these regulations is not just a legal obligation, but an ethical responsibility to ensure fair use of shared spectrum and to prevent harmful interference to other licensed services. Incorrect approaches analysis. One incorrect approach would be to immediately implement aggressive power adjustments or channel changes solely based on performance metrics without verifying their regulatory compliance. This could lead to exceeding legal power limits, causing interference to other services, and violating FCC Part 15 rules, which govern unlicensed radio frequency devices. Such actions are a direct regulatory failure. Another incorrect approach would be to ignore performance anomalies that might indicate potential interference issues, assuming they are minor or transient. If these anomalies are, in fact, caused by or contributing to exceeding regulatory limits for out-of-band emissions, spurious emissions, this inaction constitutes a regulatory failure. It also represents an ethical failure to maintain a responsible and compliant network. A third incorrect approach would be to rely on vendor default configurations or best practices that are not specifically validated against the current regulatory landscape of the operating jurisdiction. While vendor defaults are often designed with compliance in mind, regulatory requirements can change, and specific deployments might push the boundaries. Failing to verify these defaults against current regulations is a risk that can lead to unintentional noncompliance. Professional reasoning. Professionals should adopt a systematic decision-making process. First, thoroughly understand the performance data and its potential root causes. Second, cross-reference any proposed solutions or observed behaviors with the specific regulatory framework applicable to the deployment environment. This involves consulting official regulatory documents and guidelines. Third, prioritize solutions that are both technically effective and demonstrably compliant. If a performance issue cannot be resolved within regulatory constraints, escalate the issue to management or legal counsel to explore alternative, compliant solutions, or to understand the implications of potential deviations. Continuous education on regulatory changes is also crucial. Question 12. The monitoring system demonstrates intermittent packet loss and elevated latency on the guest Wi-Fi SSID, impacting a critical business application used by visitors. The issue appears to be localized to a specific building wing. What is the most appropriate initial troubleshooting step to isolate the root cause? Option A. Advise all users in the affected wing to disconnect and reconnect their wireless devices to refresh their network connections. Option B. Immediately reboot all access points in the affected wing to clear any potential temporary software glitches. Option C. Escalate the issue to the wireless vendor support team, providing them with the observed symptoms. Option D. Verify the physical connectivity and status of access points serving the affected wing, checking for any link degradation or power issues. The correct answer is D. Verify the physical connectivity and status of access points serving the affected wing, checking for any link degradation or power issues. Explanation. This scenario presents a professional challenge due to the critical nature of wireless network availability and performance in a modern enterprise environment. The monitoring system's demonstration of intermittent packet loss and elevated latency on a specific SSID, impacting a critical business application, requires immediate and precise troubleshooting. The challenge lies in identifying the root cause efficiently without disrupting other services or introducing new security vulnerabilities, all while adhering to established operational procedures and potentially regulatory compliance requirements related to network uptime and data integrity. Careful judgment is required to balance the urgency of resolution with the need for a systematic and documented approach. The correct approach represents best professional practice because it prioritizes a structured, data-driven investigation that aligns with common IT service management frameworks and Cisco's recommended methodologies for wireless network troubleshooting. By first verifying the physical layer and then systematically moving up the OSI model, the engineer ensures that fundamental issues are ruled out before investigating more complex configurations or potential interference. This methodical process minimizes the risk of misdiagnosis and ensures that the solution addresses the actual problem. Furthermore, documenting each step in the findings is crucial for knowledge sharing, future reference, and demonstrating due diligence, which can be important for audit trails and compliance. An incorrect approach that involves immediately rebooting access points without a clear hypothesis or data to support this action, is professionally unacceptable. This is because it is a brute force method that can mask the underlying issue, leading to recurring problems. It also risks disrupting other users and services unnecessarily. From a regulatory or ethical standpoint, this approach demonstrates a lack of due diligence and a failure to follow a systematic troubleshooting methodology, which could be seen as negligent if it leads to prolonged downtime or data corruption. Another incorrect approach, such as immediately assuming a client-side issue and advising users to reset their devices without investigating the network infrastructure, is also professionally unsound. This shifts the burden of troubleshooting without evidence and can lead to user frustration and wasted time. Ethically, it fails to provide adequate support and can be perceived as dismissive of the user's reported problem. It also bypasses the responsibility of the IT department to ensure the network is functioning correctly. A third incorrect approach, such as immediately escalating the issue to a vendor without performing basic diagnostic steps, is premature and inefficient. While vendor support is valuable, it should be leveraged after internal troubleshooting has been exhausted. This approach can lead to unnecessary delays and costs. Professionally, it indicates a lack of confidence in internal capabilities and a failure to follow a standard escalation procedure. Regulatory or ethical concerns might arise if this leads to prolonged service disruption that could have been resolved internally. The professional reasoning process for similar situations should involve a clear understanding of the reported symptoms, a hypothesis-driven approach to troubleshooting, and a systematic progression through diagnostic steps. This includes 1. Gathering detailed information about the problem, 2. Forming a hypothesis based on the data, 3. Testing the hypothesis through targeted diagnostics, 4. Analyzing the results, and 5. Implementing a solution and verifying its effectiveness. Throughout this process, maintaining clear communication with stakeholders and documenting all actions and findings are paramount. This structured approach ensures efficient problem resolution, minimizes disruption, and upholds professional standards. Question 13. Analysis of a scenario where a company is deploying a new fleet of smart environmental sensors throughout its enterprise facilities. These sensors collect data on temperature, humidity, and air quality, and will be connected wirelessly. The organization has a robust existing wireless network infrastructure designed for employee access and corporate resource utilization, secured with WPA3 Enterprise. The IT team is tasked with integrating these new EOT devices securely, without impacting the performance or security posture of the existing network. The team is considering several approaches for connecting these sensors. Option A. Create a new SSID specifically for the EOT sensors and secure it using WPA2PSK with a strong, complex pre-shared key. Option B. Connect the EOT sensors to the main corporate wireless SSID, which is already secured with WPA3 Enterprise, without any additional specific configurations for these devices. Option C. Deploy a dedicated VLAN for the EOT sensors. Authenticate them using WPA3 Enterprise with a radius server for individual device authentication, and configure appropriate firewall rules to restrict their access to only necessary internal resources and cloud services. Option D. Implement a separate SSID for the EOT sensors and allow them to connect using an open network, no authentication, to simplify deployment and management. The correct answer is C. Deploy a dedicated VLAN for the EOT sensors. Authenticate them using WPA3 Enterprise with a radius server for individual device authentication, and configure appropriate firewall rules to restrict their access to only necessary internal resources and cloud services. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless network design, balancing the need for robust security with user experience and operational efficiency. The introduction of a new EOT device, particularly one with potentially sensitive data or network access requirements, necessitates a thorough risk assessment and a well-defined implementation strategy. The professional challenge lies in selecting the most appropriate security posture without unduly impacting network performance or introducing vulnerabilities. This requires a deep understanding of wireless security protocols, network segmentation, and the specific security capabilities of the new devices. Correct approach analysis. The correct approach involves implementing a dedicated VLAN for the EOT devices, coupled with a robust authentication mechanism such as WPA3 Enterprise with a Radius server. This strategy represents best professional practice because it adheres to the principle of least privilege and network segmentation. By isolating EOT devices onto their own VLAN, any potential compromise of these devices is contained, preventing lateral movement to more critical network segments. WPA3 Enterprise, utilizing EAPTLS or similar methods, provides strong authentication for each device, ensuring only authorized devices can connect. This aligns with general cybersecurity best practices and the security objectives outlined in Cisco's recommended wireless security frameworks, which emphasize granular control and defense in depth. Incorrect approach is analysis. Using a shared VLAN with existing user devices and a pre-shared key, PSK, is a significant regulatory and ethical failure. PSK is inherently less secure as it relies on a shared secret that, if compromised, grants access to all devices on the network. Sharing a VLAN with user devices violates network segmentation principles, exposing sensitive user data and corporate resources to potential risks from compromised EOT devices. This approach is professionally unacceptable as it demonstrates a lack of due diligence in risk management and a failure to implement industry-standard security controls. Implementing a separate SSID with WPA2 PSK for the EOT devices, while offering some isolation, is also a professionally deficient approach. WPA2 PSK, like WPA3 PSK, is vulnerable to brute force attacks and does not provide individual device authentication. This means that if the PSK is compromised, any device can join the network, negating the intended security benefits of isolation. Furthermore, WPA2 is an older standard and lacks the advanced security features of WPA3, such as protected management frames, PMF, which help prevent deauthentication and disassociation attacks. This approach falls short of modern security best practices and exposes the network to unnecessary risks. Allowing the EOT devices to connect to the main corporate wireless SSID without any specific security configurations is a critical regulatory and ethical failure. This approach completely disregards network security principles and exposes the entire corporate network to potential threats from the EOT devices. It demonstrates a severe lack of professional responsibility and a failure to adhere to basic cybersecurity hygiene. Such an action could lead to data breaches, compliance violations, and significant reputational damage. Professional reasoning. Professionals should approach such implementations by first conducting a thorough risk assessment of the new devices, understanding their connectivity requirements and potential security implications. This should be followed by designing a network architecture that incorporates segmentation and strong authentication. The decision-making process should prioritize security, compliance with organizational policies and industry best practices, and the principle of least privilege. When evaluating security options, professionals should consider the latest security standards and their suitability for the specific device and network environment. A layered security approach, combining network segmentation, strong authentication, and ongoing monitoring, is crucial for maintaining a secure and resilient wireless network. Question 14. System analysis indicates that a healthcare organization is implementing a new suite of EOT medical devices that will transmit patient data wirelessly. These devices are known to use proprietary communication protocols and have limited built-in security features. The organization must ensure compliance with HIPAA regulations regarding patient data privacy and security. Which of the following implementation strategies best addresses these requirements? Option A. Connect the EOT devices directly to the primary corporate wireless network SSID, relying on the existing network security policies to protect patient data. Option B. Place the EOT devices on the existing guest wireless network, as it is already segmented from the main corporate network. Option C. Create a new SSID for the EOT devices that allows unrestricted access to all internal corporate network resources, assuming the devices are trusted. Option D. Deploy the EOT devices on a dedicated VLAN, isolated from the main corporate network, with strict access control lists, ACL, applied to permit only necessary communication to authorized servers, and utilize a separate SSID with WPA3 Enterprise authentication for device connectivity. Correct answer is D. Deploy the EOT devices on a dedicated VLAN, isolated from the main corporate network, with strict access control lists, ACL, applied to permit only necessary communication to authorized servers, and utilize a separate SSID with WPA3 enterprise authentication for device connectivity. Explanation: scenario analysis. This scenario presents a common challenge in enterprise wireless network design, balancing performance requirements with the need for robust security and compliance. The organization operates in a regulated industry, implying that data handling and network access must adhere to specific standards. The introduction of a new EOT device with unique communication patterns and potential security vulnerabilities necessitates a careful assessment of its impact on the existing wireless infrastructure. The challenge lies in integrating this new device without compromising the security posture or the performance of critical business applications, all while remaining compliant with relevant regulations. Correct approach analysis. The correct approach involves a thorough risk assessment and the implementation of granular security policies tailored to the specific needs of the EOT device and the organization's regulatory environment. This includes understanding the device's communication protocols, data sensitivity, and potential attack vectors. Implementing a dedicated VLAN for the EOT devices, coupled with strict access control lists, ACL, and potentially network segmentation, ensures that the device's traffic is isolated and controlled. This aligns with best practices for network security and regulatory compliance, as it minimizes the attack surface and prevents unauthorized access to sensitive corporate resources. The use of a separate SSID with strong authentication mechanisms further enhances security by ensuring only authorized devices can connect. This proactive and layered security strategy is essential for maintaining a secure and compliant wireless network. Incorrect approaches analysis. Connecting the EOT device directly to the main corporate wireless network without any segmentation or specific security controls is a significant regulatory and ethical failure. This approach exposes the entire corporate network to potential threats originating from the EOT device, which may have inherent security weaknesses. It violates the principle of least privilege and increases the risk of data breaches, leading to non-compliance with data protection regulations. Implementing a separate SSID, but allowing it to access all corporate resources without any access restrictions is also a failure. While an SSID provides a degree of logical separation, unrestricted access negates the security benefits. This approach still allows the potentially vulnerable EOT device to interact with critical business systems, creating a high risk of unauthorized access and data compromise, thus failing to meet regulatory requirements for data security. Deploying the EOT device on a guest wireless network without proper isolation from internal corporate resources is another critical failure. Guest networks are typically intended for external visitors and should be strictly segregated from the internal network. Allowing an internal EOT device to connect to a guest network, especially if it has any form of access to internal resources, bypasses intended security boundaries and creates a significant compliance risk. Professional reasoning. Professionals must adopt a risk-based approach to network implementation. This involves understanding the business requirements, the technical capabilities of new devices, and the regulatory landscape. The decision-making process should prioritize security and compliance by 1. Identifying all potential risks associated with the new device and its integration. 2. Evaluating the sensitivity of data that the device will handle or have access to. 3. Researching and understanding all applicable regulatory requirements. 4. Designing a network architecture that implements layered security controls, including segmentation, access control, and authentication. 5. Documenting all design decisions and security policies. 6. Regularly reviewing and updating security measures as threats and regulations evolve. Question 15. The monitoring system demonstrates intermittent client connectivity issues on the guest Wi-Fi SSID during peak business hours. Network logs from several access points in the main conference area show a high rate of client disassociation events, but the access points themselves remain operational and associated with the wireless LAN controller. The wireless LAN controller's client statistics show a fluctuating number of connected clients for this SSID, with no obvious overload. Which of the following troubleshooting steps is the most appropriate initial action to diagnose the root cause of the intermittent client connectivity? Option A. Contact end users reporting issues and gather detailed information about their device types and specific connection problems. Option B. Immediately reboot all access points serving the guest Wi-Fi SSID to clear any potential temporary glitches. Option C. Examine the radio frequency RF environment of the affected access points for potential interference and analyze the access point logs for specific reasons cited for client disassociations. Option D. Initiate a full network diagnostic scan across the entire wireless infrastructure to identify any widespread configuration anomalies. Correct answer is C. Examine the radio frequency RF environment of the affected access points for potential interference and analyze the access point logs for specific reasons cited for client disassociations. Explanation. This scenario presents a professional challenge due to the critical nature of wireless network availability and performance for business operations, coupled with the need to adhere to specific Cisco implementation guidelines for enterprise wireless networks. The monitoring system's alert regarding intermittent client connectivity on a specific SSID, particularly during peak hours, necessitates a systematic and informed troubleshooting approach. The professional challenge lies in quickly and accurately diagnosing the root cause without disrupting ongoing services or violating best practices outlined in the 300-430 ENWLSI exam syllabus. This requires a deep understanding of wireless protocols, Cisco's recommended configurations, and the ability to interpret monitoring data effectively. The correct approach represents best professional practice because it aligns directly with the systematic troubleshooting methodologies emphasized in the 300-430 ENWLSI curriculum. By first examining the access point app logs for client association/disassociation events, and then correlating this with the controller's client statistics, a network engineer can efficiently pinpoint whether the issue is localized to specific APs or a broader controller-level problem. This methodical progression, starting with granular device logs and then moving to aggregated controller data, allows for rapid isolation of the problem domain. This aligns with Cisco's recommended troubleshooting frameworks, which prioritize understanding the device and controller behavior before escalating to more complex network-wide analyses. Adhering to these established practices ensures efficient problem resolution and minimizes the risk of introducing new issues. An incorrect approach that involves immediately rebooting all access points without initial investigation is professionally unacceptable. This action, while sometimes a last resort, bypasses the crucial diagnostic steps required by the 300-430 ENWLSI exam's focus on understanding network behavior. It represents a failure to apply analytical troubleshooting skills and could mask the underlying issue, leading to recurring problems. Ethically, it demonstrates a lack of diligence and a disregard for systematic problem solving, potentially causing unnecessary downtime and impacting user productivity. Another incorrect approach, such as solely relying on end-user reports without consulting network infrastructure logs, is also professionally flawed. While user feedback is valuable, it is often subjective and lacks the technical detail needed for accurate diagnosis. The 300-430 ENWLSI exam emphasizes the importance of objective data from network devices. Ignoring AP and controller logs means missing critical information about signal strength, interference, client roaming behavior, and potential hardware or software faults. This approach fails to leverage the available diagnostic tools and information, leading to inefficient troubleshooting and a higher probability of misdiagnosis. A third incorrect approach, such as immediately assuming a firmware bug and planning a widespread firmware upgrade without evidence, is premature and risky. While firmware issues can occur, they are not the most common cause of intermittent connectivity. The 300-430 ENWLSI syllabus stresses a layered troubleshooting approach. Jumping to a firmware upgrade without first analyzing logs and client behavior is an unsubstantiated action that could introduce new vulnerabilities or instability if the actual problem lies elsewhere, such as in RF interference or configuration errors. This bypasses the systematic analysis required for effective enterprise wireless network management. The professional decision-making process for similar situations should involve a structured, data-driven approach. First, clearly define the problem based on monitoring alerts and user reports. Second, consult relevant device logs, app, controller, and performance metrics. Third, form hypotheses based on the data and test them systematically, starting with the most likely causes. Fourth, implement solutions incrementally and monitor their effectiveness. Finally, document the process and resolution for future reference. This aligns with the principles of effective network troubleshooting and best practices for implementing and managing Cisco enterprise wireless networks, as covered in the 300-430 ENWLSI exam. Question 16. Research into the implementation of secure wireless network access for a healthcare facility handling sensitive patient data has revealed a critical need to balance high availability for medical devices with stringent data privacy regulations. The IT security team is evaluating different wireless security protocols and authentication methods. Which of the following approaches best satisfies the requirements for robust security, compliance with data privacy laws, and seamless operation of critical medical equipment? Option A. Implement WPA3 Personal SAE to provide enhanced security for individual client connections. Option B. Implement an open wireless network with no encryption to ensure maximum accessibility for all medical devices. Option C. Implement WPA3 Enterprise with a Radius server for centralized authentication and authorization. Option D. Implement WPA2 PSK with a strong, complex pre-shared key distributed to all authorized users and devices. Correct answer is C. Implement WPA3 Enterprise with a Radius server for centralized authentication and authorization. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise wireless network design, balancing performance requirements with the need for robust security and compliance. The organization's reliance on sensitive patient data necessitates strict adherence to data privacy regulation, while the demand for seamless connectivity for medical devices and staff requires high availability and low latency. The challenge lies in selecting a wireless security protocol that meets both these critical and potentially conflicting demands. Failure to implement appropriate security can lead to data breaches, regulatory penalties, and loss of patient trust. Conversely, overly restrictive security can impede the functionality of essential medical equipment and workflows. Correct approach analysis. The correct approach involves implementing WPA3 Enterprise with a robust Radius server for authentication and authorization. This aligns with best practices for enterprise wireless security and is crucial for meeting regulatory requirements related to data protection, such as HIPAA in the U.S. context, assuming U.S. jurisdiction for this exam. WPA3 Enterprise offers significant security enhancements over WPA2, including stronger encryption, GCMP 256, protection against brute force attacks, and individualized data encryption for each client. The use of a Radius server allows for centralized authentication of users and devices, granular access control based on roles and policies, and detailed logging for auditing purposes. This comprehensive approach ensures that only authorized users and devices can access the network, and that the data transmitted is protected, thereby meeting the stringent security and compliance mandates for sensitive patient information. Incorrect approaches analysis. Implementing WPA2 PSK, pre-shared key, is a significant regulatory and security failure. PSK relies on a shared secret password, which is inherently less secure than individual authentication. It is difficult to manage securely in an enterprise environment, prone to weak password usage, and offers no mechanism for individual user accountability or granular access control. This directly violates the principles of data protection and auditability required for sensitive data. Implementing WPA3 Personal SAE is also an incorrect approach in this enterprise context. While WPA3 Personal offers improved security over WPA2 PSK, it is designed for simpler networks, like home networks, and does not provide the centralized authentication and authorization capabilities necessary for an enterprise environment handling sensitive data. It lacks the robust user and device management features that a Radius server provides, making it impossible to enforce granular access policies or maintain detailed audit trails required by regulations. Implementing an open network with no security is a catastrophic failure from both a security and regulatory standpoint. It exposes all network traffic, including sensitive patient data, to unauthorized access and interception. This would result in immediate and severe regulatory penalties, a complete breach of patient confidentiality, and irreparable damage to the organization's reputation. Professional reasoning. Professionals must adopt a risk-based approach, prioritizing security and compliance when dealing with sensitive data. The decision-making process should involve understanding the specific regulatory landscape, e.g., HIPAA, GDPR, etc., depending on the exam's jurisdiction, identifying the types of data being transmitted, and assessing the potential impact of a security breach. Implementing a layered security strategy that includes strong authentication, encryption, and access control is paramount. For wireless networks, this translates to selecting protocols and authentication methods that support these requirements. Continuous monitoring, regular security audits, and staying abreast of evolving threats and best practices are also critical components of professional responsibility. Question 17. Strategic planning requires a comprehensive evaluation of wireless network security protocols to ensure robust protection of enterprise data and compliance with U.S. regulatory frameworks. Considering the evolving threat landscape and the availability of advanced security features, which of the following approaches best balances security, performance, and manageability for a large enterprise environment? Option A. Utilize WPA3 Personal for its ease of setup and strong encryption, suitable for all network segments. Option B. Deploy an open wireless network with no authentication to ensure maximum accessibility for all users and devices. Option C. Continue using WPA2 Enterprise, as it provides adequate security for most enterprise needs and avoids the complexities of a protocol upgrade. Option D. Implement WPA3 Enterprise, leveraging its advanced encryption and authentication mechanisms for enhanced security and a clear upgrade path. The correct answer is D. Implement WPA3 Enterprise, leveraging its advanced encryption and authentication mechanisms for enhanced security and a clear upgrade path. Explanation. This scenario presents a common challenge in enterprise wireless network design, balancing the need for robust security with the practicalities of user experience and network performance. The professional challenge lies in selecting a security protocol that not only meets the stringent requirements of enterprise-grade security, but also aligns with the capabilities and limitations of the deployed wireless infrastructure and client devices, all while adhering to relevant U.S. regulatory frameworks for data protection and network access. Careful judgment is required to avoid over-provisioning security, which can lead to performance degradation and user frustration, or under-provisioning, which creates significant security vulnerabilities. The correct approach represents best professional practice because it prioritizes the implementation of WPA3 Enterprise. WPA3 Enterprise offers significant security enhancements over WPA2 Enterprise, including stronger encryption, GCMP 256, protection against brute force attacks through SAE, simultaneous authentication of equals, and improved protection for sensitive data in transit. This aligns with U.S. regulatory expectations for protecting sensitive enterprise data, such as that covered by HIPAA for healthcare or PCI DSS for payment card information, by providing a more secure authentication and encryption mechanism. Furthermore, WPA3 Enterprise is designed to be backward compatible with WPA2 Enterprise, allowing for a phased rollout and minimizing disruption. Implementing WPA2 Enterprise without considering the upgrade path to WPA3 Enterprise is an incorrect approach. While WPA2 Enterprise is a strong security protocol, it has known vulnerabilities, such as crack key reinstallation attack, that are mitigated in WPA3. Relying solely on WPA2 Enterprise without a plan to migrate to WPA3 could be considered a failure to implement the most current and robust security standards available, potentially falling short of the reasonable security expected under various U.S. data protection laws. Implementing an open network with no authentication is a severe regulatory and ethical failure. This completely disregards any obligation to protect sensitive enterprise data and violates numerous U.S. regulations, including those mandating data confidentiality and integrity. It creates an unacceptable risk of unauthorized access, data breaches, and potential legal liabilities. Implementing WPA3 Personal is also an incorrect approach in an enterprise setting. WPA3 Personal is designed for home networks and uses a pre-shared key, PSK, for authentication. This is not scalable or manageable in an enterprise environment and does not provide the granular user authentication and access control necessary for corporate networks, which is a fundamental requirement for compliance with enterprise security policies and U.S. data protection laws. A professional decision-making process for similar situations should involve a thorough assessment of current and future security requirements, an evaluation of the existing and planned wireless infrastructure's capabilities, and a review of relevant U.S. regulatory mandates. This includes understanding the security features and limitations of different Wi-Fi security protocols, considering the impact on user experience and network performance, and planning for a phased implementation that minimizes risk and disruption. Prioritizing security protocols that offer the strongest available protection while remaining practical and compliant with industry standards and regulations is paramount. Question 18. Market research demonstrates that enterprise wireless networks are increasingly susceptible to interference, impacting user experience and productivity. In a U.S.-based enterprise environment operating within the 5 GHz unlicensed spectrum, what is the most responsible and compliant approach to mitigate potential interference and ensure optimal network performance while adhering to FCC regulations? Option A. Manually assign static channels to access points based on initial site surveys, overriding any automated DFS functions to ensure consistent channel selection and prevent perceived performance degradation. Option B. Implement a dynamic channel selection mechanism that actively monitors spectrum usage, adheres to dynamic frequency selection (DFS) requirements, and automatically adjusts channel and power levels to avoid interference with radar systems and other users. Option C. Utilize a channel selection algorithm that prioritizes channels with the lowest reported signal strength from neighboring access points, without explicit consideration for radar detection or DFS compliance. Option D. Deploy access points with fixed, high-power transmission settings across all available channels to maximize coverage, assuming that increased signal strength will overcome any potential interference. The correct answer is B. Implement a dynamic channel selection mechanism that actively monitors spectrum usage, adheres to dynamic frequency selection (DFS) requirements, and automatically adjusts channel and power levels to avoid interference with radar systems and other users. Explanation. This scenario presents a professional challenge due to the critical need to balance network performance and user experience with the regulatory requirements of wireless spectrum usage. The chosen jurisdiction for this exam is the United States, and therefore, all regulatory and ethical considerations must align with U.S. federal laws and FCC guidelines. Careful judgment is required to ensure that any proposed solution adheres to these mandates, preventing potential legal repercussions and ensuring fair access to the radio frequency spectrum. The correct approach represents best professional practice because it prioritizes compliance with U.S. regulatory frameworks, specifically the FCC's rules governing unlicensed spectrum e.g. 2, 4 GHz and 5 GHz bands. By implementing a solution that dynamically adjusts channel selection and power levels based on real-time spectrum analysis and adherence to DFS, dynamic frequency selection, requirements, the network operates within legal boundaries. This proactive stance ensures that the wireless network does not cause harmful interference to other licensed or unlicensed users, which is a core tenet of FCC regulations. It also demonstrates a commitment to responsible spectrum stewardship, a key ethical consideration in network deployment. An incorrect approach that involves overriding DFS or manually assigning channels without considering potential interference sources fails to comply with FCC Part 15 rules. This can lead to significant penalties, including fines and the requirement to cease operations. Ethically, it demonstrates a disregard for the shared nature of the radio spectrum and the potential negative impact on other users, including critical services like weather radar. Another incorrect approach, such as ignoring the impact of channel overlap and simply selecting the least congested channel based on a static scan, can still lead to interference issues, albeit potentially less severe. While not a direct violation of a specific rule, it falls short of best professional practice by not employing the robust mechanisms designed to prevent interference, thereby risking noncompliance and user dissatisfaction. Professionals should employ a decision-making framework that begins with a thorough understanding of the applicable regulatory landscape, FCC rules in the U.S. This should be followed by a comprehensive site survey and spectrum analysis to identify existing users and potential interference sources. The selection of wireless equipment and configuration settings must then be guided by these findings, with a strong emphasis on features that support regulatory compliance, such as DFS and dynamic channel selection. Regular monitoring and auditing of the wireless network's performance and spectrum usage are crucial to ensure ongoing compliance and to adapt to changing environmental conditions. Question 19. Which approach would be most appropriate for implementing a new enterprise wireless network in a dense office environment, prioritizing both high user throughput and efficient spectrum utilization within the existing regulatory framework for unlicensed 5 GHz Wi-Fi bands? Option A. Deploy Wi-Fi 5, 802, 11AC Wave 2, focusing on maximizing channel width to achieve the highest possible individual client data rates. Option B. Configure all access points to operate on the same high bandwidth channel to simplify management and provide dedicated bandwidth for critical applications. Option C. Utilize older Wi-Fi standards like 802.11n in the 5 GHz band to ensure maximum compatibility with legacy devices, accepting lower overall throughput. Option D. Implement Wi-Fi 6 802.11ax with features like OFTMA, MU-MIMO, and BSS coloring enabled to maximize spectral efficiency and minimize co-channel interference. Correct answer is D. Implement Wi-Fi 6 802.11ax with features like OFTMA, MU-MIMO, and BSS coloring enabled to maximize spectral efficiency and minimize co-channel interference. Explanation. The scenario presents a common challenge in enterprise wireless network design, balancing performance requirements with the need for efficient spectrum utilization and compliance with regulatory mandates. The professional challenge lies in selecting a configuration that not only meets the immediate needs of the organization, but also adheres to the principles of responsible spectrum management, which are implicitly governed by the regulatory framework for wireless operations. This requires a deep understanding of how different Wi-Fi standards and their associated features impact the shared radio frequency environment. The correct approach represents best professional practice because it prioritizes a configuration that is both effective and compliant. By selecting a standard that offers robust performance while also incorporating features designed to mitigate interference and optimize channel usage, the network administrator demonstrates a commitment to efficient spectrum management. This aligns with the underlying intent of regulatory frameworks, which aim to ensure fair access and minimize harmful interference for all licensed and unlicensed users. This proactive stance prevents potential issues such as service degradation for other users or non-compliance with spectrum usage rules, which could lead to operational disruptions or penalties. An incorrect approach that focuses solely on maximizing data rates without considering the broader impact on the RF environment fails to acknowledge the shared nature of the spectrum. This can lead to increased interference, reduced overall network performance for all users, and potential violations of regulatory guidelines regarding out-of-band emissions or excessive power levels. Another incorrect approach that ignores newer, more efficient standards in favor of older, less capable ones represents a missed opportunity for optimization and can result in suboptimal performance and inefficient spectrum usage, indirectly contributing to congestion. An approach that disregards the need for interference mitigation features, such as dynamic frequency selection or transmit power control, directly undermines the principles of good spectrum stewardship and can lead to significant operational problems. Professionals should approach such decisions by first understanding the specific performance requirements of the enterprise. Subsequently, they must evaluate available wireless standards and technologies against these requirements, always considering their impact on the shared RF spectrum. This evaluation should include an assessment of interference mitigation capabilities, spectral efficiency, and compliance with relevant regulatory guidelines. A thorough understanding of the trade-offs between raw performance and responsible spectrum management is crucial for making informed and sustainable network design choices. Question 20. The review process indicates that a large enterprise campus network is experiencing intermittent wireless connectivity issues for mobile users moving between different building floors. While the wireless infrastructure is designed with adequate AP density, users report dropped calls and slow application performance when transitioning between AP coverage areas. The network team has proposed several strategies to address this, but there is disagreement on the most effective and compliant approach. Which of the following approaches best addresses the observed roaming issues while adhering to enterprise wireless implementation, best practices, and regulatory considerations for network stability and performance? Option A. Incrementally adjust the RSSI thresholds for client roaming on the wireless controller, starting with a conservative value and progressively lowering it based on observed roaming events and client performance metrics, while ensuring that the chosen thresholds are well above the minimum signal strength required for stable communication. Option B. Disable all roaming assistance features on the wireless controller and rely solely on client device roaming logic to manage transitions between access points. Option C. Immediately configure all access points to aggressively roam by setting the lowest possible RSSI threshold for client association and disassociation to ensure clients switch to the nearest access point as quickly as possible. Option D. Increase the transmit power of all access points to their maximum setting to ensure continuous, strong signal coverage across all areas, thereby eliminating the need for frequent roaming. The correct answer is A. Incrementally adjust the RSSI thresholds for client roaming on the wireless controller, starting with a conservative value and progressively lowering it based on observed roaming events and client performance metrics, while ensuring that the chosen thresholds are well above the minimum signal strength required for stable communication. Explanation. The review process indicates a common challenge in enterprise wireless deployments, ensuring seamless roaming between access points while maintaining optimal client performance and adhering to network design best practices. This scenario is professionally challenging because misconfigurations in roaming parameters can lead to intermittent connectivity, increased latency, and a degraded user experience, directly impacting productivity. Furthermore, incorrect settings can inadvertently increase the load on APs or the controller, potentially affecting the stability of the entire wireless network. Careful judgment is required to balance aggressive roaming thresholds for quick client transitions with the need for stable connections. The correct approach represents best professional practice because it involves a systematic and data-driven methodology for tuning roaming aggressiveness. This typically involves understanding the client device capabilities, the physical layout of the wireless environment, and the specific needs of the applications being used. By starting with conservative settings and incrementally adjusting based on observed roaming behavior and performance metrics, such as RSSI thresholds for roaming, beacon interval, and DTIM settings, network engineers can achieve a balance that minimizes dropped connections and reassociation delays. This aligns with the principle of designing for reliability and performance, ensuring the wireless network effectively supports business operations. An incorrect approach that prioritizes aggressive roaming by setting very low RSSI thresholds for AP transitions is professionally unacceptable. This can lead to clients attempting to roam to APs with weak signal strength, resulting in dropped packets, retransmissions, and a poor user experience. It also forces clients to constantly scan for new APs, consuming valuable client resources and potentially causing connection instability. Ethically, this fails to deliver a reliable service to end users. Another incorrect approach involves disabling roaming assistance features entirely or setting excessively high RSSI thresholds for roaming. This can cause clients to stick to an AP even when they have moved to an area with a significantly better signal from another AP. This leads to poor performance due to weak signal strength and can create sticky client issues, where clients are reluctant to roam even when a better AP is available, impacting overall network efficiency and user satisfaction. This represents a failure in professional due diligence to optimize the wireless environment. Finally, an incorrect approach that relies solely on default roaming settings without any tuning or validation is also professionally deficient. While defaults are often a reasonable starting point, they are rarely optimized for a specific enterprise environment. Failing to validate and adjust these settings based on the unique characteristics of the deployment means the network is likely not performing at its best, potentially leading to suboptimal roaming behavior and user complaints. This demonstrates a lack of proactive network management and optimization. The professional decision-making process for similar situations should involve a phased approach. First, understand the requirements and constraints of the environment. Second, implement a baseline configuration based on best practices and vendor recommendations. Third, Conduct thorough testing and monitoring using appropriate tools to identify roaming issues. Fourth, iteratively adjust roaming parameters based on observed data and user feedback. And finally, document all changes and their impact. This iterative and data-driven process ensures that the wireless network is not only functional, but also optimized for performance and reliability.